Continuing with problem 5 on the handout, we now want to graph the equation a of x is equal to negative 2x squared plus 240x, negative b over 2a, or negative 240 over 2 times negative 2 will give us 60. Plug 60 back into the area equation, get 7,200. The y-intercept is easy. You plug in 0 for x, you get 0 for y. It is always a good idea for a couple of different reasons to sketch the graph before you go looking for the x-intercepts. So you find the vertex and the y-intercept and then sketch it. Well, we can see that we know the y-intercept, since we know the y-intercept is 0, that point is 60 away from the x-coordinate of the vertex. Therefore, because of symmetry around the axis of symmetry, we know for a fact that the other x-intercept has to be 120. So 120, area is 0, and at 0, the area is 0. Now that we know what's going on, the fact that making the width larger always makes the length smaller, it makes more sense to look at the shape and how the increase of the width does cause a decrease in the area at some point. So obviously, again, if your width is 0, your area is 0. As you increase the width, the length increases because you're getting more and more and more area. But at some point here at a width of 60 and an area of 7,200, we are now making the width so high that the length, we're getting that the length is making the garden so skinny that we have less and less and less area. What does this point mean right here? This point 120, 0. Okay, it means that all of the fencing is going into the two lengths, and there's nothing left for the width. So here, if the length is 120, the width is 0, and again, the area will be 0. So I think you can go through all these questions and fill them in yourself. And let me at least get you started with number 6. Again, it'll be one I think you can finish yourself. Notice something a little bit different is going on here, only because we're saying we're putting the garden in the middle of the property. So all 4 sides of the garden need fencing. What do you think that's going to do to your maximum area? All right, well, let's put the whole thing together now. So we'll have x and a of x. Here's x, z, z. This time it's 2x plus 2z. That will give us the 240 feet of fencing altogether. I solve for z. 2z is equal to 240 minus 2x. Z is equal to 120 minus x. So instead of saying that this length of this side is z, we can say it has a length of 120 minus x. Therefore, the area, length times width, is x times 120 minus x, which can be written as negative x squared plus 120x. So from here, why don't you go ahead and figure out what the maximum area is, and see if you can also figure out how this problem relates to the one right before.